Hey there. Something that I had to do recently was convert a bunch of hair cards that had been groomed for sort of game level characters and turn it into a groom of actual splines so that they could be rendered as hairs and be much nicer quality potentially in renders rather than just having hair cards and textures. You could use this technique to create a base level groom, I guess, but you could also use it to just brute force create a full final hair count groom out of this rather than just some sparse guides. But this technique could be used for both. So I thought that I would just quickly run through it, and people might be interested in it. So I have a set of hair cards here groomed along. And this is the setup that I sort of constructed that ended up working quite well and quickly to solve it. So we have our hair card geometry coming in. There's nothing crazy there. I'm just doing some cleaning of attributes that may have been on there just to make things a little bit nicer when you're playing around in Houdini. So the first things first is I'm just going to use an assemble sub to create a name attribute for the primitives for each separate card, and we're going to use that later on. So it's currently created it and it's packed it, so it's all cool. We've got something there, and it's easy to select stray ones, and we might want to blast them or delete them out. I'm just unpacking them, and in a for loop I'm just using a UV fuse based on this set of parameters, mainly because I found that some of these hair cards could have discontinuous UVs, so could have broken UVs, and this definitely doesn't help with this method. So ideally you would have nice UVs in the setup, but if you don't, then the fuse is a good way to sort of solve that problem, so that when you cycle through and it's quite quick and easy to do, you can obviously go through and step through each one of these and prove that it's actually created nice workable UVs, and we sort of go from there. I'm just, this is quite sparse geometry, and we would just want to do some basic subdivision on it. The topology doesn't matter because we're going to remesh, but this is just to give us, a curved, a better silhouette as to work off as a base, as opposed to something that is quite, faceted. I'm not going to step through the remesh, that'll take a bit of time, so I've already cached that out. So it's just remeshed. I don't know why the remesh seems to be doing something funny to the display, but it doesn't matter because this is just a nice piece of remesh geometry that we're going to use in a sec for this setup. So here is the meat and potatoes of it. It's been encapsulated in a compile block, which Waffle Tom suggested I do because it would definitely paralyze it and make it much faster. So I think it was about 10 or 15 seconds to do this normally, but with this in compile block, it's actually, I think it's a second or so or less. So definitely a really good performance increase in this setup. So we'll just set this to step mode so that we can actually cycle through and see what we're doing in this. So just going to view this hair. So this is one hair card with its remeshed state, and we've just got it still sitting in world space. It's all cool bananas. But what I thought was, how are we going to solve this? How are we going to try and grow curves on here that are orientated along the UVs? Everything's going to behave. It can get quite tricky to try and sort of solve and think about this stuff in 3D space. So my first thought was not to do that. My first thought was to transform them into UV space. So it's not doing anything special. It's just taking the UVs and fitting it. So we've got -1 and 1, and then giving our constant so that we're in the right space, and then just outputting that to position. So the geometry is now flattened and it's in UV space in theory. It's still in world space, but its values have been flattened out to be using the UV coordinates. So that's all cool. I've done a generic spline, just 2 points on it, and we're just using a match size just so that we can get the same length that's applied to this as what is the length of the hair card. I'm also doing a little bit of bounding box math in here just so that I can determine how many strands of hair would go into each hair card, so that the thinner the hair card is, the less amount of strands, and the thicker it is, the more amount of strands, so that the overall hair density is consistent and the same when you get to the end. So we're just, resampling it, we're duplicating it, and the duplication, you can see how many strands we have here, and that's tied into that strand calculation that we're doing here. So obviously we can, we can have as many strands or as few as we want. All cool. And I'm just using a symbol here so that I get a unique name attribute that we'll have here. I've got a unique name attribute per curve. There we go. So we've got a unique one here, and we're just gonna enumerate through it so that we get a unique index integer. And I'm just promoting that back to point so that each strand has a unique index attribute, and the reason for that we'll show you in a second. It'll make sense. So we've got the curves, they're all cool. We've got values, we've got curve view, everything works. So we've got pretty much what we need here. I'm just going to blast the actual polygons away for the curves, and we're left with just the points. But the points have the unique index per strand, and they have the curve view values along those points as well. So we've still got everything we actually need. What I'm going to do next is I'm just going to use XYZ distance to take the flattened UV position of this piece of hair card, sample this and spit out the primitive, with the source primitive that we have, so the closest source primitive to one of these points, and it's parametric UVs. It's intrinsic UVs that go from 0 to 1 for every polygon. So we've captured where that is, what primitive number and what UV position, and we're storing that on each one of these points. And all we really need to do after that point is we just use an attribute interpolate, and it's just looking for those two attributes. And what is it going to do? It's going to transform those points back into world space. So we have nice building blocks for curves. They are correctly positioned. They have curve view doing the right thing, and we have a unique index ID with which to construct some curves from. And that's what we'll do here with the add sop like you've always used. So there we go. We've got a bunch of curves. They're in world space with curve view, and they're all correct. Set some basic width on here just so that we've got something. And I'm just copying back the name that I originally had. So there we go. I mean, it looks pretty boring now, but we're going to jazz it up in a sec. So the next step here is we're just going to untick this, and you can see that it's going to be, taking a little bit of time. It's going through 976 cards. That wasn't too bad. In a compile block, it is almost instantaneous. It's much quicker inside of a compile block. So thank you, Tom, for pushing me to do that. And there's our curve view represented there. So we have the nice values from 0 to 1 along the length of that, and we can use that to map width and frizziness and all types of stuff. So all I'm doing here is doing a bit of attribute creation, and we're using that to drive some unique per hair randomness, just so that they don't all get the same noise applied to them. And yeah, there you go. You have, obviously it's not going to be the most elegant looking groomed hair because you're at the mercy of the cards, but this is where you could come back and say, well, I'm just going to use this as a base groom. So you could take the strand spacing and make it much sparser, and there you go. You've got a basic set of building block splines to bring in and do a more elegant groom from. But let's say that we're not doing that. We're just going to keep this as the full count. You can see how quick that was too. So all I'm going to do here is adjust the width of this hair based on curve view and just mapping it with the normal taper towards the end of the hair. So there you go. And this is all looking pretty good, and obviously if we took this up fatter, the hairs would be thicker. I think I'm just coloring this just to show you that each hair card is doing its jazz, and then obviously a final width multiplied depending on if I'm actually going to render this. So that's it. That's the kind of nuts and bolts of the quick walkthrough of how to do this. One last thing, if you are not seeing the width of this kind of stuff in your setup, that just means that you need to come to the miscellaneous tab and shade open curves in the viewport, and that's how you can actually get the actual, so if we change maximum width here, you would see. So that's how you would get your actual display of those guys. and then that's it. And we sort of spit it out after that, and then we can render it all done. So, yeah,